Good morning, everyone. We will be talking about completing the square in this lesson, as well as the square root method for solving quadratics. Now, the process of completing the square, we're going to talk about more in depth next week, but the process of finding a constant c to add to x squared plus bx so that x squared plus bx plus c is the square of a binomial. So when I say a square of a binomial, here's a binomial, x plus 3. That's a binomial. And if we square that, we have a binomial squared. And if I write that out, it's x plus 3 times x plus 3. Now, this diagram they give us over here is very similar to our box method. Okay? And so we kind of have this box right here, right? And this box right here. And right here we have a box. And right here we have a box. Now, one big square, that's called an x squared term. These are what's called algebra tiles, right? If I take away the boundaries that I just drew, right? We could draw the boundaries around the outside. Maybe I should use a highlighter here. That'll be a little better. Right? This one box right here, the upper left corner, that's an x squared. And then these longer rectangles, these are called x tiles. These are x's, and these ones down here that are horizontal are also x's. And then these little squares are ones. So what we really have with these algebra tiles is x squared. We have 3x in the top corner, 3x in the bottom corner, and 9 in the bottom right-hand corner. Now, if we do our factoring, like we have been, right, the common factor here amongst these terms is x. The common factor here is 3. The common factor this way would be x. And the common factor this on the bottom row is 3. So if you look at this, it's really, the factorization is x plus 3 times x plus 3. So what they're showing you is that with these algebra tiles, you can model the product of a binomial that is squared. Okay, if you have a binomial squared, it makes a perfect square. It's a perfect square trinomial. In that it's a perfect square trinomial because the factors on the sides, x plus 3 and x plus 3, are the same. Now we'll come back to that some more next week with these tiles, but these algebra tiles absolutely represent what we've been talking about with the box method when we've been factoring. All right, moving on to the square root method. We have x squared equals 9. And so when I look at that, x squared equals 9, I'm going to square root both sides to remove the square. And when I take the square root on both sides, I need to use a plus or minus in front of our solution, right? And that would give me plus or minus 3. Now another way to write this is x squared equals 9. X squared is really x times x. So we're saying what number times itself gives me a positive 9? Well, that could be 3 times 3 gives me positive 9. And negative 3 times negative 3 also gives me positive 9. So when I take a square root on both sides of an equation, I always need a plus and a minus in front of my solution, a plus or minus, because what that really means is that we have two solutions, negative 3 and positive 3. All right, solving by finding square roots. When we want to solve by finding square roots, you can use the following steps to solve equations using the square root method. 1, isolate the squared term on one side of the equation. Get the x squared term by itself. Then we're going to take the square root of both sides. Remember that every non-zero number has 2 square roots. Use plus or minus as a symbol, and then simplify completely. So when we look at this, we have 2x squared plus 9 equals 13. What we're going to do is get the squared term by itself. Step 1 says isolate the squared term. So 2x squared is the squared term. Okay, so I'm going to take 2x squared and I'm going to subtract 9 on both sides, and that gives me 2x squared equals 4. Now, before I take the square root, I have to remove the coefficient in front of x squared. You have to remove any numbers in front of this squared term. So I'm going to divide both sides by 2, because we're multiplying x squared by 2. To undo that, we divide by 2. That gives me x squared equals 2. Now again, x squared equals 2 means that we would have x times x equal to 2. What number times itself equals 2? I don't know that off the top of my head, so I'm going to square root both sides, and that gives me the square root and the square cancel each other out, just like addition and subtraction cancel each other out, and multiplication and division cancel each other out. I'm going to cancel the square root with the square, and I get plus or minus square root of 2. So what that tells me is that square root of 2 times square root of 2 is equal to 4. No, is equal to 2, excuse me. Is equal to 2. And negative square root of 2 times negative square root of 2 is 2. All right, in example 2, we have to get the squared term by itself. So I'm going to go ahead and add 10 to both sides. I get 7x squared. The 10s are canceling out there. 35 plus 10 on the other side is 45. I'm going to divide by 7 here on both sides. And I get x squared equals 45 over 7. And then to remove the square on the left side, I'm going to square root both sides. That gives me x equals plus or minus the square root of 45/7. So another way to write that is to say the positive square root of 45/7 and the negative square root of 45/7, or the opposite of the square root of 45/7. So you can write that either way there. So this would be one way to write it, and down below, if I separate the solutions as a positive and a negative solution, that's how you would write it. Okay, what we're going to do now is talk about solving a perfect square trinomial equation. Okay, again, a perfect square trinomial is one where I could make a box. We would have a box here with x squared. Remember, we split up the negative 14x. That would be negative 7x and another negative 7x. And then a positive 49 at the bottom. Right? Now, when you do the algebra tiles, you would break that up into like 7 long rectangles like this. Right? You would have 7 x tiles. And I'm not going to draw all 7, but you would have 7 of those here in this box right up in the corner there. So what we're going to do is we are going to factor, and we know that we're going to factor x squared minus 14x plus 49. I'm going to leave the 25 there for right now because I know that this is a perfect square trinomial, right? We could multiply, we want to multiply to be 49 and add up to be negative 14, right? If we multiply 1 times 49, we get 49, and we want to add up to be negative 14. Well, that's negative 7 and negative 7. So if I split that up, x squared minus 7x minus 7x plus 49 is exactly what I had in the box over here to the left. So if I factor out the common factor here, I get x. On bottom, I'm going to pull out a negative 7. On top, if I look at x squared and negative 7x, that would be x. And then I would also put a negative 7 on top here. Negative 7 times negative 7 is positive 49. So my factorization is x minus 7 times x minus 7, which is equal to 25. X minus 7 times itself is really x minus 7 to the second power. Something times itself is that thing squared. If I square root both sides to get rid of the square, that leaves me with x minus 7 because the square root and the square cancel. And remember, when we take the square to both sides, we need a plus or minus in front of our solution. So the square root of 25 is what number times itself gives me 25? That's positive 5 or negative 5. We get plus or minus 5 there. And if I separate out my solutions, I get x minus 7 equals positive 5, and x minus 7 equals negative 5. So this plus or minus means there could be a positive 5 there or a negative 5 there. So we say x minus 7 equals positive 5, and x minus 7 equals negative 5. If I add 7 to both sides, I get x equals 12. And if I add 7 to both sides here, I get x equals 2. So my solutions to this equation, the values of x that I could plug in and get 25 on the right side are 12 and 2. Right? We can always go back and check. I can check my work and say 12 squared minus 14 times 12 plus 49 should equal 25. And I could also get 2 squared minus 14 times 2 plus 49 is equal to 25. If I simplify 12 squared, I get 144. 14 times 12 is 168, so I get minus 168 plus 49 equal to 25. 144 minus 168 is negative 24, and if I add 49 to that, I do get 25. So we get 25 is equal to 25, so 12 is definitely a solution. Down here, if I take 2 squared, I get 4. 14 times 2 is 28, plus 49. 4 minus 28 is negative 24, plus 49 is definitely equal to 25. So both positive 12 and positive 2 are solutions to our equation. Okay, moving on to letter B. We are going again to factor this perfect square trinomial. And if I multiply 1 times 25, that gives me 25. I want to multiply to be 25 and add to be 10. That would be 5 times 5. So if I break up the middle term, it's x squared plus 5x plus 5x plus 25 is equal to 100. I'm going to leave the 100 hang out for the time being. And I'm going to factor x squared and 5x and 5x and 25. That's going to give me an x here and an x here. And 5x and 25, my common factor would be 5. And same thing, looking at the vertical column here, the common factor of 5x and 25 is positive 5. So we actually end up with a factorization of x plus 5 times x plus 5 equal to 100. X plus 5 times itself is x plus 5 squared. Now I can remove the square by square rooting both sides. And I get x plus 5, square and square root cancel out. I get x plus 5 equals plus or minus the square root of 100. The square root of 100 is actually what number times itself gives you 100, which is 10. So I get x plus 5 is equal. So x plus 5 is equal to positive 10, and x plus 5 is equal to negative 10. Positive 10, x plus 5 is equal to negative 10. We have both a positive and a negative 10 there. If I subtract 5 on both sides, I get x equals 5. And if I subtract 5 here, I get x equals negative 15. So our two solutions are 5 and negative 15. Okay, I will let you guys try letter C. So why don't you go ahead and pause the video and see if you can come up with the solution for letter C. Okay, if we look at factoring the left side here, 4 times 9 is 36. What numbers multiply to be 36 and add to be negative 12? That would be negative 6 and negative 6. So I get 4x squared minus 6x plus 9 equals 49. If I break this up to factor it, 4x squared minus 6x plus 9. If I factor in the top row, that's going to be a 2x. If I factor in the first column, that's also a 2x. So 2x times 2x is 4x squared. That means I'm going to have a negative 3 here because 2x times negative 3 is negative 6 in the top right-hand corner. And 2x times negative 3 would give me negative 6 in the bottom corner as well. And then negative 3 times negative 3 would give me positive 9. So I have 2x minus 3 times 2x minus 3 is equal to 49. The 49 just carries down on the right side. I get 2x minus 3 squared. Something times itself is that thing squared. I'm going to remove this square. If I square root both sides, I get 2x minus 3 because the square and the square root cancel. And that's going to give me plus or minus the square root of 49 on the right side. So I get 2x minus 3 equals plus or minus the square root of 49. What number times itself gives you 49? That's 7. So I get 2x minus 3 equals a positive 7, and 2x minus 3 equals a negative 7. So if I solve for x, I get 2x equals 10. Divide by 2, and x is equal to 5. And over here, if I add 3 to both sides, I get 2x equals negative 4. Divide both sides by 2. X is going to give me negative 2.